All right, I have another video for you about base 12 geometry and base 12 math. In this video, I'm going to be talking about the Fibonacci sequence and what it looks like when we approach it from a base 12 perspective. So first of all, I just want to let you know I have written a book recently called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dozanal Geometry. It's available through Amazon. So in this book, I introduce a new geometric pattern that no one's aware of because you have to find it or discover it, or it exists on the base 12 Cartesian plane, which is a Cartesian plane that is denser than base 10 because the length of 1 is divided into 12ths instead of tenths. So that's the main difference between base 10 and base 12. It's the size of the decimal place. So usually when we talk about base 12, or when people have talked about base 12 in the past, you usually think, well, we're simply rearranging our numbers in groups of 12 instead of 10. So therefore, even though the number looks different, it's still the same number. And so ultimately, it doesn't really make a difference. And so mathematicians have sort of dismissed the idea of exploring or working in base 12 because it's just confusing and there's no real advantage, or there wasn't any advantage perceived from the standpoint of base 10 kind of looking at base 12 saying, well, it's just the same number but written differently. But what I've discovered is because when we go into the decimal places, there is a difference, and that actually creates a different type of Cartesian plane where the points where all the lines, the horizontal and vertical lines cross each other. Because those are all in different places, the possibility of simply connecting dots that weren't there before reveals new patterns. So that's what that book's about, introducing a new geometric pattern that has to do with the geometry of the circle and 360 degrees, and ultimately a different version of pi that emerges from a geometry of the circle that we haven't been aware of. So in this video, I want to kind of go step sideways from that a little bit and just share what I've discovered about the Fibonacci sequence. So this sequence is usually represented or presented as a sequence of numbers that are whole numbers. So we start with 1, and then we add the number before, which is 0. So 1 plus 0 is 1 for our next number. And we have this pattern. So you're always, to get the next number in the sequence, you add the previous number to the one before it. So the pattern goes 1, 1, and then 2, as 1 and 1 is 2, then 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and so on. I think you can see that here. So what I've done is just simply written the same numbers in their base 12 equivalent. And so you can see it's 1, 1, 2, 3, 5, 8 is all the same, and then it looks like 1, 1. So you have one group of 12 plus 1 is 13. One group of 12 plus 9 is 21. It looks like 19. So it is the same number, but in its base 12 equivalent. And we see when we get to the bottom here, after 12 iterations of that pattern, we get to the number that looks like 100, and you can see over here it's 144. So that's the conversion of how you do base 12 to base 10 or base 10 to base 12 right there. So what I wanted to put forth is the idea that how do you know when you're counting in a certain base? In base 10, you know it's base 10 when you get to 9, and then you see the 0 and you roll over. And the example I was thinking of is the odometer in a car. When you're driving along, you can see it counting 1, 2, 3, and literally you get to 0, 9, 0, then the next number counts up and it starts again. And then as that number gets to 9, then 0, then you have 100. And then that keeps going. So it's a slow process to grow the number. I think we're all familiar with how that works. So it's when the zeros arrive, when you sort of know that you're in the base. The base has been defined by how many numbers went before. So a different base, you would have a different amount of numbers counting up to your 0. So I just found it interesting that the zeros show up here in the Fibonacci sequence. You can sort of see them in base 12. And so that's the first section of 12. And then that series continues here, the next 12 numbers. And we see it happens again. We get another pair of zeros here on the second number, on the second section of 12. And then here's the third, and basically we don't see that in base 10. The base 10, there's no real pattern visible. And I've checked to see if anyone's talked about the patterns in Fibonacci. And there has been mention of sort of a 12ness, an awareness of the 12ness, but it doesn't really come into focus until you actually engage in base 12. So here we have this big number. It's a 5 with 3 zeros and the 3, and then again 2 zeros at the end. And then continuing again after 12, we get 2 zeros at the end. Now, after a while, it starts to not be surprising. And I want to share with you something a little, maybe you've seen it already, but if I've drawn put in the zeros here. So if we just look at this block of numbers, and then this sort of block here of the 2, so good, just like that a little bit, like that. You'll notice 01, 01, 02, 03. Right here, we got the same thing happening again. 01, 01, 02, 3, 5. And this exact same block as what is over here shows up again. So again, the idea, it's very much like the odometer. And again, here it has, looks like, it's like, I guess that's 705, 705, 2A, A3, 705, 705. Again, you see I'm saying 705 instead of 75. I'm really wanting to make it clear that it is different, you know. So that pattern keeps repeating over and over and over again. That's like the odometer going through the Fibonacci sequence. And this is interesting. I made the effort to continue this pattern for 288 iterations. Not 144, like you'll see how it's 12 and then 24 before it repeats. So instead of doing that complete pattern 12 times, you'd have to do it 24 times. Then the second column repeats. So you put zeros here, you have zeros all the way down to that 1, and then it goes 1, 1, 2, 4, 6, B, 5, da da da, and it carries on that whole pattern. That doesn't, right now, it's all different. And it's all different for 288 numerals, and then it repeats again. So you have that same thing of there's a pattern in there where it's building up just like an odometer. So I thought that was really interesting, so I wanted to share that with you. And then you can think about, well, this idea of the decimal place. What if we were to start, instead of saying it's an integer, we just put a decimal in there and say this is 0.01. So we're on our graph paper, instead of saying it's 1, we say it's 0.01. So we have that 0, 0, 0, 0, then 0.11, 0.19, 0.2, and then when we get here, suddenly we have the length of 1. And I think that's always interesting when the length of 1 pops up in a pattern, because it kind of anchors it somehow, and it can have a relationship with other geometric patterns. So there's the length of 1. So this is the length of, 2A, which is sort of like that, but not exactly, because we're taking off the zeros. It's a bit different. And here's something I noticed yesterday. I was making a video about Pythagorean triplets, and there's a Pythagorean, and it's the same thing. If you put the decimal place in there, suddenly the number changes, and when it's decimals, then we're talking about different lengths. It's not exactly the same as what we're used to in base 10. If we put a decimal place in base 10, the 0.1 is different. So we're talking about different sized lengths in relation to the length of 1. And there seems to be interrelations between this geometry, Pythagorean triplets, and the geometry that I introduced in my book, Understanding Base-12 Math, How to Draw the Perfect Circle Using Dozenal Geometry, available through Amazon. All the geometry of the circle. So this is the geometry of the spiral. Okay, so I got the grid here. I'm going to see if I can squeeze this in at the end here. So what we're counting, what these numbers are actually counting, is quarter circle sections. So if I'm going to start here, right, I'm going to start here for you and draw a quarter circle. That's our first one. And then I don't move the point of my compass. And I draw another quarter circle like this. And then, so I'm gonna put 0, and then I move it 1 back. From there, I go 1 back like that, and then I've added my 2, and I draw a 2, a radius of 2. And then I go 2, and from there I go back 3, and I draw 3 like that. So what we're doing is we're increasing the radius of the circles. Okay, so I'm going to run out of my 10 minutes, so I'm going to just leave it right there and say thanks for watching, and I hope you enjoyed that, and I don't know, like and subscribe.